In this lecture, we'll discuss the various ways to establish a more secure architecture in AWS. We'll briefly talk about AWS Shared Responsibility Model and how to secure your data both at rest and in transit. The AWS Shared Responsibility Model determines who is responsible for which system, if it is AWS or if it is you, the customer. This depends on which AWS service that you are using. In our AWS General Knowledge Review section, we discussed the three basic types of AWS service, namely the infrastructure services, the container services, and the abstracted services. Infrastructure services like EC2 instances gives you a lot of control to the resource. Container services like RDS only provide a restricted control to the underlying resource. This service is also called managed services. Lastly, abstracted services like S3 and DynamoDB does not give you access to the underlying resource. It is also called a fully managed service. Each type of service has a different shared responsibility model. For infrastructure services, you are responsible for the operating system, server-side encryption, firewall configuration, and many others, while AWS is responsible for the foundation services such as compute capacity, storage, and database. For container services, AWS takes care of the operating system of the underlying server for you, including the application management, platform management, and the usual foundation services layers that it handles. Lastly, for abstracted services, all of the resources are now handled by AWS, including the IAM service. You are only responsible for your own data. You can secure your data by encrypting it before uploading it in the service, and AWS will handle all of the underlying resources needed. This is what it means when we say fully managed service. AWS is fully managing the service for you. Let's discuss how to secure your data both at rest and in transit. There are a lot of data security issues that may happen on your data, including accidental information disclosure, accidental deletion, spoofing, system or software failure, and data integrity compromise. Let's start off with S3. In S3, you can enable cross-region replication, object versioning, and multi-factor authentication or MFA to secure data at rest. You can also enable CORS, IAM policies, and access control lists to restrict data access, including pre-signed URLs. There are also client and server-side encryptions that you can use to add another layer of protection. In EBS, you can enable encryption and create snapshots to secure and replicate your data. Just take note that in EBS encryption, you're securing all data between EC2 and EBS volumes. However, this does not include the data traveling from your EBS volume to S3 when you create a snapshot. In RDS, you can create various encryption functions for each database that you are using. For MySQL, use the built-in cryptographic functions. For Oracle, enable the Oracle Transparent Data Encryption, and for Microsoft SQL, enable the Microsoft Transact SQL data protection functions. To secure your data in transit, you can use SSL instead of just a plain HTTP. The IPsec connections can also be configured to use authentication headers and encapsulating security payloads or ESP for added protection as well. Amazon CloudFront, ELB, and EC2 instances are the AWS resources that can be configured with SSL. You should also know the difference between a self-signed certificate, a third-party certificate, and a default certificate generated by the AWS service. And listen, another important rule that you must abide is to never ever store your SSL certificates in EC2 instance nor in an S3 bucket. This poses a security risk, and these certificates should be stored in IAM or ACM instead. SSL termination is where the SSL connection terminates. It is best to terminate the SSL at the ELB layer instead in the EC2. This strategy provides you with more control and improved performance as well.